Hey kids, Mr. Murray here again for Mr. Murray's Mathland channel, and we're taking a look at the extreme value theorem today. The extreme value theorem states that for a function, if that function is continuous over a closed interval, so over an interval a to b, if it's continuous over a closed interval, no holes, no VAs, or any sorts of discontinuities, then it must have a maximum and a minimum value. And that maximum minimum value, which it must have, will either occur at an endpoint of the interval or at a critical number within the interval. Okay, so there's the summary of the idea here, that if the function is continuous, it must have a maximum value, it must have a minimum value, even, by the way, if it's the same value. If, for example, it's a horizontal line, the maximum value it reaches is the same as the minimum value. It's whatever that constant is. And since it must have a maximum and a minimum value, that will occur at either one of the endpoints of the interval, at A or B, or at a critical point within that interval. So we are taking this as a sample problem here. Find the maximum and minimum values for this function. Nice polynomial here, so the derivative will be very easy, so we won't get bogged down with that. But we're going to use what we call in calculus the candidates test. The candidates test for maximums and minimums. And by the way, when it just says maximum and minimum value, it doesn't specify relative or absolute. It's implied, when somebody says, hey, the maximum value, the minimum value, we are talking about the absolute maximum and minimum values. So here we go. The candidates test means you basically think about what are the candidates for the maximums, maxima or minima, would either be at one of the endpoints of the interval, which would be at -3, since this is the interval, -3 to 3, or at the right endpoint of +3, or if there's any critical point that happens there in the middle. So critical points here, remember, are when you find the derivative and anywhere where that derivative is 0 or undefined. So our derivative is 3x squared minus 6x minus 24. This is never undefined. We set it equal to 0. You can factor out a 3. 3x squared minus 2x minus 8. That can further be factored to x minus 4, x plus 2. And our two solutions are x equals 4 and x equals -2. Okay, except 4 is outside of the interval, so we don't even care about that value. Don't even bother. We're only looking for values that are between -3 and 3. So that would be -2, certainly. And this, you may think that, hey, couldn't we just make a table? Couldn't we just make a table and plug in every value between -3 and 3? But remember, there's no guarantee that these maximum or minimum values happen at an integer value. For all I know, it could happen at -1.75234. But because we're using calculus here, we're obtaining there's only one critical point. That kind of rules out all the other values. So, and it just so happened it was a nice integer value. But this value I got just as easily could have been some, random, irrational, or non-integer value. So that is why you always want to check that. You can't just plug in integers and hope. So now I'm going to plug these values into this function. Not into the derivative, into the function. So f of -3, f of -2, and f of 3. I just want to see what are those y values at those 3 spots. So f of negative 3, that would be negative 3 cubed is negative 27, minus 3 times negative 3 squared, that'll be minus 27 again. Negative 3 times negative 24 will be positive 72, minus 10. So that's going to give us negative 54, minus 10, negative 64, plus 72. That's going to give us positive 8. So we've got positive 8 here. F of negative 2, the critical point in the interval. So when I plug that in, I get negative 8 minus 3 times negative 2 squared. So that'll be minus 12 plus 48, 24 times 2, minus 10. And we're going to get negative 20 minus 10, negative 30, plus 48 is going to give us 18. Very nice. F of 3, 27, minus 27, minus 72, minus 10. 27 minus 27 cancel each other out. Negative 72 minus 10, minus 82. And so now you're essentially just looking at these y values. What's the biggest? What's the smallest? So here we go. The biggest y value I got was 18. That's the maximum value. And when they say value, maximum, minimum value, you're always talking about the output of a function, so the y value. The x value is where it occurs. We'll talk about that in a minute. And the smallest value we got out was negative 82. So sometimes questions will ask you for the coordinates of the maximum or minimum. Sometimes they'll just ask for what is the value. If they only ask for the value, they are only asking for the y value. But this is why I always like to answer these with a sentence. That way it's you're covered no matter what, and I think it shows your understanding. So I like to just say the max value is 18. And I like to say which occurs at x equals negative 2. That way you're telling the person where it occurs and what the value is, and you're demonstrating you understand the difference between the two. And the minimum value is negative 82, which occurs at x equals 3. And so there we go. There's our answers, I guess, and we're good. But like a lot of times, let's keep building that visual, connection, that graphic understanding. So let's just take a look at the graph here. I'm bringing in the graphing calculator here, the TI simulator, and there's the equation. If I were to look at this graph, of course, I don't know what kind of viewing window your calculator might be on, but mine's on the standard window, negative 10 to 10. This isn't showing me that much. So what I like to do is I like to set this window to be the window I was looking at. If I only care about from negative 3 to 3, why not set it at negative 3 to 3 so you're not distracted by anything that occurs outside of there? Now the y values, you can use your values, your output to judge. Seems like the smallest y value I got is negative 82. So maybe I'll just set it a little bit lower than that, negative 85. Seemed like the biggest y value I had was 8, I believe, or 18, excuse me. So maybe I'll set that a little bit higher at, say, 25 or 30. And just let's take a look at the graph here. Let's just make sure things seem to be making sense. And you see this, you're just taking a little snapshot of this polynomial graph from negative 3 to 3, just chopping out a little portion of it. And if you turn your trace on and you can scroll around, you can actually tell it to go to negative 2, for example. And you should see, hey, that's the highest point. In this window, that is the highest point there is, and the y value is 18. And you can see that the lowest point is at the very, very right of the window, which would be at x equals 3. So, trace 3. You put it there, the y value is negative 82, and that's it. So you really, your results are confirmed graphically. It's very nice. Now, if you were to keep scrolling and looking at this, you'd see that, of course, that's not the lowest value on the graph, but in this window it is. So that's what it's all about, is just on this little snapshot of your graph. Okay, kids, that's it for that example. I've got a second video coming up with a second example. Feel free to check it out or not, whatever you like. But hang in there and keep working hard.